In this video, I want to demonstrate that it's not that hard to start learning practical networking on Cisco routers and switches. A lot of times we feel that we need to have a lot of equipment or real equipment and spend a lot of money. But as we've talked about for other solutions, other environments like the cloud, we don't need to spend a lot of money. So here's a very simple way to study. Many times we feel that we need to have this gigantic network with 20, 30, 40 routers, but you can do a whole lot with just 2. And these are virtual, these are free. So if we go to configuration mode, and let's do the IP addressing, let's look at the interfaces. So this is G00 between R1 and R2. And we'll give them an IP address. In order for tracking purposes, since it's a connection between router 1 and 2, let's make it a 12 network. So we're going to interface G00 and we do IP add 12.12.12.1, make it a 24-bit subnet mask, no shut-in. Okay. And as well here, and we will make interface G00 part of that 12 network, 12.12.2. And like I mentioned, this is just for, oops, forgot to put the IP address in front. And like I mentioned, this is just IP addressing, so we can distinguish the connections. A lot easier to study and troubleshoot if we have it that way. And we have our interfaces up, so let's ping between them. And we have connectivity. Very simple, right? Nothing out of this world. It's probably something that you know very well. But we're going to get deeper and deeper into this, and I'm going to create more videos, so please subscribe and hit that notification bell. So let's continue moving forward. Now here's one way that you can replicate having multiple networks that then you start filtering. And we'll get into that in a little bit. But right now, let's configure router EIGRP on this, and we only want it for that interface. And we make it a 0. That's question mark. So now I want to wildcard bits. So in your studies, you've learned that this is the opposite of what you had as the network mask. So a 24-bit would be represented this way, 0.0.0.25. Okay. So what this command does, it runs EIGRP only on that interface, EIGRP network 12.12.12.0, and the wildcard mask is 0.0.0.255. In a previous video, we talked about aliases, so let me do that while I'm here. Show run pipe SRE. Okay, so I'll do SRE. Okay. And we see that there. And let me do another alias for that. SIR show IP route. Alias exec. SIE show IP EIGRP. EIGRP to alias. And now what we want to do is to make sure that we are seeing, okay, do SIE and topology, and we have that, or we do SIE neighbor, and we have connectivity, we have adjacency between the two, as we see here. Okay, so how can we make this a little bit more complex, because this is sometimes the problem that new students have, or new people into networking have. Well, there's the concept of loopback interfaces. A loopback interface is something that's virtual, but for all intents and purposes, it can work for you just like in another connection. You can even pretend that it's a separate router altogether. Let's pretend that. We'll create two interfaces here. So interface loopback 0, and let's call this, because it's loopback 0, let's call it one. Let's put it in the 10.network, 10.0.10.10.1. And you only need to make this a 32-bit mask. So all 255s. Okay. And this will not work. You have to put the IP address in it. Okay. Now let's create another interface. Let's loopback 1. And because it's loopback 1, this is just for tracking purposes. We'll make it 11.11.11.1. 255, 255, 255. And let's leave router 2 for now as is. And so if we do a show IP route, we only see the 12.network. That is the connection between R1 and R2 on the gig interface. So if we wanted to add these interfaces to our EIGRP and have them come or be sent over to router 2, we just have to add them with the network command. So let's have the first one, 10.10.10.1. And we'll do the 0.0.0. And that should be that network. We can do a show IP route. You see that with a D means EIGRP. This route was learned because we added it to the networking statement. But we don't see 11. And that's very simple. We add 11. Network 11.11.11.1. And once again, we're matching the 32-bit. We'll come to router 2, SIR, or show IP route, and there it is. So we've made very complex networks. And I shouldn't say very complex networks, it's actually a very simple network, but you've added complexity to the network. Now let's say that router 1 has another network. Let's make a network. Let's create another loopback 2. And this one we'll put in the 2. We'll make it 2.2.2.1. And we have to add the mask 255, 255, 255, 255. But you do not want this network advertised in EIGRP. So you don't want router 2 to know about this network. Well, that's very simple. You don't have to do anything with it. It does not get advertised because it's not in your EIGRP statement. So if we check our show run section router EIGRP. Now you can see why I like to use aliases. So these are the networks that are advertised in your EIGRP, and these are the networks that are seen here. Okay, so we have that set up. But let's remove that no interface loopback 2. There we go. But now let's take it in a different direction. Let's imagine that router 2, this site, does not want to get any information about one of these networks for whatever reason. So remember, router 1 is advertising 10.10.10.1 and 11.11.11.1. One thing that we could do is we can block that advertisement from coming into our router. So R2, as you can see, is receiving these routes. Very simple process that you can do. We create an access list and always question mark it. Okay, so you could either do IP access list and then you get these statements, or you could just do access list question mark and you put a number. Let's just say 1 for this, question mark it. Now we're trying to block one of these advertisements. So what do you think we would have to put in here? Permit or deny? Well, let's say we want to deny this. Deny, and let's deny the 10.10.10.1. And we could just hit enter here, or we could put the wildcard bits. Let's see what happens with each one. Okay. And now we go into router EIGRP, router EIGRP1, and let's see what commands we have here. So here you find distribute list, and it says the purpose is to filter entries in EIGRP updates. Okay, that sounds like what we want. So let's do a distribute list, question mark it, and we can call it something, or we could just actually you can use the access list name or the number, and our number was distribute list 1. And because it's coming in from router 1, we'll use the in. And we could specify an interface. So this is coming in on gigabit, and it was 00. And we hit enter. And we just wait a few seconds and see if anything changes. Let's go here. So let's do a show IP route. And as you can see, the neighbor changed. And what routes do we have here? And we only have the 12.12, which is part of that network. So let's do the show router EIGRP section. And we see that it only has that network statement, which is correct because we're not advertising any other networks. And let's see, show EIGRP neighbor. And our neighbor is up, so we are good. What do you think happened? Well, if we do a show access list, we're denying that, and that's the reason why that one's not coming in. But remember, we have network 11.11.11.1, and we want that one to show up on router 2. We want to accept that from router 1. Well, this is very simple. And let me do a show run section access. It's very simple. As you can see, or as you should know, every access list has a deny statement at the end. So for example, access list 1 deny 10.10.10.1, but there's nothing after it. The implicit deny denies every other route. So you can't just end the access list like this. So what we need is access list 1, permit any, and that should be it. And now this will reset the neighbor once again. And we do a show IP route. And the neighbor still hasn't come up. But once the adjacency comes up, we should see that in here. Okay. So here we go. And as you can see now, we see the 11.11.11.1 network here. The D here tells us that it was learned by EIGRP. And nothing has changed on router 1. So if we do a show, and this is why I like the aliases, because there's just so much less typing. Even though here you could just do SRE, but the command would be like this: show router EIGRP. Oh, I already did that part. It's here goes section router EIGRP, in which you could achieve the same thing like that. So we are advertising 10.10.1, 11, 12, but because we are blocking it, you see, it's also got 3 matches on it, because as the packets are coming in, it sees that this address is in there and it blocks it. But we need this permit any statement at the end, so that any other route coming from router 1 is accepted. And this is what you see here. Now you could say, well, that's very simple. And that is true. What I am trying to demonstrate is that you can start getting more and more complex with just 2 or 3 routers. A lot of times students get very confused because they try to build these huge networks without understanding the fundamentals. So you need to understand these fundamentals. Very simple, very easy to implement, but there are a couple gotchas. So if you ever implement a distribute list inbound on one of your routers because you don't want that advertisement, remember, you have to permit any at the end of this access list, or else the implicit deny will block all updates. You won't get anything. You might bring down the network. So very simple. And you could do this, you could implement this access list anywhere you want, or distribute list anywhere you want. Well, I hope you've learned something with this video. I'm going to try to continue to make more of these and to demonstrate hands-on what you can do with very little. You could run this simulation on a very weak laptop, weak PC. You don't need a lot of resources to run this. And it's just a good way to learn, a good way to practice, and that way you get your hands dirty.